In keeping with the theme of talking machines, I'll be today talking about talking machines in the context of buildings. Specifically, and why buildings? Because buildings are where we are spending most of our time, whether it's in the office, commercial buildings, or in our homes, which is a residential building. So typically a commercial building subsumes many subsystems, right? For example, there is a subsystem which is monitoring and controlling the air conditioning, typically called as heating, ventilation, and air conditioning, a HVAC subsystem in the building. Then there is a subsystem for access control. So we all use access cards to get into different parts of the building. Then there's a subsystem for lighting, so that may be controlled based on the motion. And there's a subsystem for plug loads. So for an IT building, all these plug loads have typically IT infrastructure like laptops, desktops, or printers on them. So what typically happens is that each of these subsystems are individual subsystems, which are their verticals, but they don't talk to each other. And what is more challenging in these talking machines in building context is that there's a human aspect to it. So we are living in the buildings. So these systems have to be aware of the occupants that are living and their preferences, right? So a preference of one person may be different from the preference of the other person. So an ideal system should incorporate the preference of both the people and accordingly do the control. Right? So this is where potentially the advancements in IT and many of you can contribute a bit in creating these human-aware building management systems. And these systems should be such that they scale from small residential homes all the way to the commercial buildings, and possibly even federation of the buildings, where, for example, in this Satyam campus, there may be multiple buildings and you want to control many of these buildings together with a common subsystem, with a common system. So the primary aspect that comes out from this brief discussion is we want to make building management systems that are human aware, right? So what does that really mean? In the context of commercial buildings, in the context of residential buildings, is that these subsystems should monitor and sense human activities and accordingly provide the feedback in a way that can affect our mindset such that we change our behavior, if at all required, to optimize the behavior of many of these subsystems. So let's take a specific example of energy consumption, because that spans across many of these subsystems, right? In lighting, there is energy consumption. In air conditioning, there is energy consumption. In plug loads, there is energy consumption. And specifically, when we come to our homes, we are the ones who are paying the high electricity bills these days. So we also care about energy consumption in our homes as well. So when it comes to energy consumption, a human-aware building management system can be intelligent enough such that it combines the access control system with the air conditioning system. In a simple way that, for example, on weekends, if there are people who may be coming to the office for certain work, then since not everyone is coming to the office, the access control system can tell the air conditioning system who all are in the building and where potentially are they sitting, so that only those specified spaces get conditioned and not the whole building. So you save a lot on the energy consumption by not conditioning the whole building and just conditioning the small spaces which are occupied by people who are in the building, right? Such that you don't compromise on the comfort factor of the occupants while still make sure that you reduce energy, which will contribute back to the bottom line in terms of money, as well as will contribute back in terms of the overall reduction in the energy consumption. The second buildings are important because we spend a lot of time in the buildings. The second reason why buildings are important is that statistically, buildings consume more than 40% of the total energy consumption of the country. And there are numbers that tell that every year in India, in the name of development, we are adding about 20 million meters square in terms of both residential and commercial building spaces. And with more and more electronics coming in, there is more and more consumption that we are doing for energy. So buildings, while they are already consuming a significant proportion, they will be consuming more and more with the advent of many more buildings, and many more consumer electronics that are now flooding the market. So knowing that buildings are important and we can do some smart things in the commercial building space by interconnecting many of these subsystems like access control and the air conditioning system. I think the area that is important is when it comes to our home, because that is where we pay the electricity bill, right? In the office, we come, we use energy, but the bill is not being paid by us. In fact, many of us may not even know that just for energy consumption of this whole building, there may be more than a crore of electricity bill that this company will be paying every year, right? So when it comes to our home, what we want is to reduce the electricity consumption, right? Because for many of us, the electricity bill on an average every month, at least in Delhi where we use a lot of air conditioning also because of the weather conditions, is about 3,000 to 4,000 a month, right? Which, by the way, is actually more than what I used to pay for electricity when I was in Los Angeles, even when I do the dollar to rupee conversion. So we are really paying a lot for the electricity that we are consuming. So there's a lot of incentive, even monetary incentive, to try to see how we can reduce the energy consumption. But as was mentioned by Ram, these systems that need to be put in place, they need to be put in place such that I, as a homeowner, need not put in effort to install these systems and then to manage these systems, right? So the broad theme that comes up is that these systems should be such that they don't affect my daily routine, right? So they don't come into picture when I'm just engaged doing my daily activities like doing bathing or watching TV or, just relaxing in the room which is air conditioned, while they still do something smart without me coming into the picture, right? So that is what we typically call as non-intrusive load monitoring. So it doesn't intrude my daily life. Plus, in a way, it is also doing non-intrusive control as well. So how do we do that, right? And again, keeping the theme in mind that occupants are very important and integral part of this whole energy conservation, right? There are studies that tell that effective information feedback to the users can itself result in behavioral change such that you can do 10 to 15% reduction without doing any smart control. So you don't need to turn off lights when there is no one in the room or do any smart control. Just tell people about how they are consuming different things, and that itself will motivate people to adopt strategies which are energy efficient. So what should I tell people? Right? So just take an example that today when we get our electricity bill, it just says number of units consumed. There is a slab for each unit consumed. So 0 to 100 is a different cost, 100 to 200 is a different cost, and so on. And then the total cost that I need to pay. And compare that to your mobile bill, which is very, very itemized. So how many SMS do you make? How many STD calls did you make? How many locals calls did you make? And accordingly, you choose the plan. Many people are now pitching. In fact, there are news articles that are saying that many state governments, including the Delhi government, are now going for time of the day pricing also, right? So depending on when it's a peak usage time, the cost of 1 unit of electricity will be more. And when it's a non-peak time, the cost of 1 unit of electricity will be less. So can I put something more in the electricity bill that may help the homeowner? Right? So what is the first thing that comes to mind? Can I do the itemization, the way we do itemization for the mobile phone? If, for example, in your electricity bill, it comes that the total electricity bill is 2,000 rupees, of which the air conditioner consumed 1,200 rupees, your refrigerator consumed 400 rupees, your washing machine consumed 300 rupees, your water motor consumed this much, your lighting consumed this much. Then you can take a lot of actions. What kind of actions? For example, let's say your refrigerator is consuming 400 rupees worth of electricity every month. If there is an energy efficient refrigerator that's out there that tells that it's a 5-star rated and it will consume so many number of units which are equivalent to, let's say, 200 rupees, you can yourself do the maths that if I do the replacement, I will save on 2,500 rupees every year, which means if I do the replacement, I pay 7,000 rupees, I'll get back the money in 3 years. So let me just replace it, which otherwise you will never do because you don't know how much is your current refrigerator consuming and how much although you may know how much the new refrigerator may be consuming, right? So these are actions you have to convince the people to proactively take. And one way to do that is to start giving them disaggregated information. So how to give this disaggregated information in a non-intrusive manner? Because one simple way is I start putting sensors on every appliance and they start giving me consumption, that how much AC is consuming, how much washing machine is consuming and all that. So this is what is called non-intrusive load monitoring. So the intuition is that each appliance has a very unique electrical signature. So my washing machine, when there's a washing cycle, it spins clockwise and then it spins anti-clockwise, because of which the reactive component of the power is positive and negative, right? So if I am only monitoring at the meter level, when I see that kind of a signature, I know that washing machine is on, right? Similarly, my refrigerator has a compressor that typically has a cycle which is 20 minutes on, 30 minutes off, 20 minutes on, 30 minutes off. And by the way, there is also a temporal information that in winters during the night, if the heater is not on, which you can tell by the amount of electricity consumption because heater would take several kilowatts of electricity, you can tell that the only appliance that is on is refrigerator. So there is a temporal information at your meter. There is also appliance signature in your meter. And then there is a sequence of events, right? So when you go and take a bath, you turn on the geyser, then you consume water. So if you're monitoring both just at the meter level, both the electricity and the water, you can combine these series of events and then say that, okay, this event belongs to geyser, right? So essentially the idea is use some machine learning and pattern recognition only at the information that comes at the meter level and then disaggregate that information into appliance level information, right? And then provide that information back to the user such that they take proactive actions and that action results in reduced energy consumption. Now that I have provided you with an information that your AC consumes this much, can I go the next step, right? So there the idea is that many news articles again tell you that if you run your air conditioning to more than 26 degrees Celsius, it's more energy efficient and all that. But look around on the web, you will never find numbers, how energy efficient it is, right? And again, it's a very simple experiment, right? So once you can disaggregate, you take the meter level information, you disaggregate and get the air conditioning consumption from there. So we did some small experiments where we saw that if I run my air conditioner and there the air conditioner, when the compressor is on, it consumes about 3 kilowatts. And then when the compressor is off, typically compressor goes off when the temperature in the room has reached the temperature setting of the air conditioner. Then the compressor goes off. And when it goes off, the fan in the air conditioner still takes about 500 watts of electricity, right? So there's a difference of 2.5 kilowatts of electricity between when the compressor is on and when the compressor is off. You set the air conditioner at 28 degrees Celsius. The compressor is on for 3 minutes and off for 2 minutes. You increase the temperature to 29 degrees Celsius. The on cycle still remains at 3 minutes. The off cycle increases to 5 minutes. You increase the temperature to 30 degrees Celsius, the on cycle still is 3 minutes, off cycle increases to 8 minutes, right? So if we do the averaging, the average power consumption at 30 degrees Celsius for my 3 kilowatt AC is actually 1.2 kilowatts, right? At 30 degrees Celsius and 1.8 kilowatts at 28 degrees Celsius. So only if I set the AC temperature from 28 to 30, I save on that 0.6 kilowatts every hour, which by the way, if we take the approximate pricing, is 5 rupees a unit. So it's 3 rupees per hour. And if I run on an average air conditioner every day for 10 hours, it's 30 rupees in a day. So which is 900 rupees in a month, I save on my electricity bill just by doing one small thing of changing the temperature from 28 to 30 degrees Celsius, right? Go anywhere, you will never find these numbers. And if I tell you these numbers, you will be very motivated to say that, look, can I change these numbers, right? But many people may still say that, look, I don't want to compromise on my comfort. When I go to bed, I still want my room to be 28 degrees Celsius. So then comes the question that, and many of us might have also experienced that when the electricity goes away, we don't realize it immediately. only when the temperature goes beyond a certain threshold, when our body starts feeling it, we realize it and then we wake up. So which means that even though I may need the temperature of 28 degrees Celsius while I'm going to bed, once I'm asleep, even if you increase it to 30, I may not wake up yet. So which means that is there a system that can learn when I went to sleep and what is the temperature that I'm comfortable with, and then automatically once I'm asleep increases the temperature of the air conditioner so as to result in energy efficiency. And these, by the way, these can be done very, very easily. So we have developed a system that can do all these things very easily. So one of the biggest challenges that not many people talk about when it comes to human-aware building management system is the data privacy and the control security. The moment I start collecting my meter data, and if I put it on the cloud, looking at meter consumption, someone can tell whether there is anyone in the home or not. If that information is leaked, it's known that, okay, during what times there is no one at home. And for how long do I watch television and all these things. So there is a breach of personal privacy. And nobody wants to put the control on the cloud because I don't want to be in the room when someone hacks into the system and starts turning on and off the lights in my room, right? So which means that what you need to do is create IT infrastructure in a way that the control of this data and the control actions remains with the user, and the user decides who to share this control with, at what times, maybe with certain modifications that the data has a Gaussian noise added to it, and then only it gets shared, and in return for certain incentives. So the utility may tell the person that, look, you have an incentive that if you give us the control of your refrigerator, which we will turn on and off when there is a peak load demand, and in return, I will give you a 4 rupees per unit electricity and not 5 rupees per unit. So then I'll be willing to share that control. And I specify that that control is shared only between, let's say, 12 in the night to 8 in the morning, because that's when I don't care too much about the refrigerator. So I'll stop here. I believe there are many opportunities in creating these human-aware building management systems where IT can really play a big role. And once these systems are put in place, then even newer opportunities can arise. For example, can we talk about systems of systems? So can we say that, look, if there's a traffic jam on the elevated highway next to your office, then let's say your air conditioning is programmed to be turned on at 8 a.m. in the morning. Then instead of 8 a.m., the transportation system tells the air conditioning system that, look, there's a traffic jam, so many people are not likely to reach on time. So please turn it on at 8:30 or delay the turning on. So we can even talk about further optimizations at systems of systems level once we start putting these optimizations at the system level. So I'll stop here by just saying that there's a huge opportunity there. We also believe that specifically in the Indian context, the opportunity is even bigger because our loads are very distributed. So we have per bathroom geyser. We have per room air conditioner, which is not the case in Europe or in US. So they have centralized cooling, they have centralized heating. Doing the management of these centralized things is much more difficult than doing the management of things which are room level. So there is a very big opportunity to do these kind of smart monitoring and control at a relatively reduced cost. So we believe these kind of systems can be easily built, which can be retrofitted in about 20 to 30,000 rupees. And you can actually make a case of energy savings that you can get from these systems in a matter of 2 to 3 years. So there's a big opportunity, and IT can play a very significant role in achieving that big opportunity. And with that, I'll stop. Thank you.
You mentioned about the security aspect. So are there any advancement on the security aspect for machine-to-machine transformation? How?
Yeah, so some of the things we have looked into is simple key managements. For example, when I register a sensor, right, or a device which has a sensor and an actuator, right, to my system, which is local to the home, right, because of security aspects and all these things, then I need to manually set a key in the device. And this is similar to, for example, your email, that if you lose the password, there's nothing we can do. So if you lose the key, there is nothing we can do, but only if the data is pushed with the key, then only data gets accepted. So there are simple key managements that we do and bring human into the picture, that human beings transfer those keys manually. right? And the other aspect we currently look at is do the transfer over IP and use HTTPS. So those are simple things we are doing. I think there is also an opportunity to develop some low weight cryptographic algorithms that can run on these small end devices. But yeah, that's not the line of work that we are currently looking at.
Are you looking at any application for critical patient monitoring using this?
Yeah, so we do believe there is a lot of opportunity. See, the way we are trying to build these things is that taking it as a middleware. So there is a system that allows you to host, let's say, local storage and control within your home on a very small Raspberry Pi kind of device, which is worth just 2,000 to 3,000 rupees, right? And then you can interface multiple devices over IP or over other protocols as well through some gateway applications. And then what you can do is we provide a certain set of APIs such that you can build applications on top of it. One of the things our system also do is we can allow users to submit tasks to the system besides the data privacy and control security. For example, you can submit a task to a system that turn on the geyser at 5:30 in the morning, right? So when it comes to those specific kind of applications, we are creating a general framework, and that task framework would allow someone that, for example, that let's say there's a tag. So you can set up a task in a very simple manner on the system that if the tag shows outside perimetry, then do this. So you can very easily set up if then if else kind of scripts. But what we are trying to say is it's a generic framework on top of which you can build many applications. And those may be very area specific, very domain specific, and the APIs just allow you to do many of those things in a simple manner.
So you were talking about the analytics model for disaggregation that you could come up with. Have you tested it, and how accurate has it been? I mean,
Yes, so actually this non-intrusive load monitoring was proposed back in 1990 by the original Hart paper or something. But in the last 5 years, many people are getting excited about it because now smart meters are reaching out to the homes. There are millions of homes now which have smart meter installed. So many people are now coming back and saying that, can I do this smart disaggregation? So we have, and typically in research also, even the state of the art would say that you can achieve about 50 to 60% accuracy. Here again, we feel there's an opportunity in the Indian context, right? See, because my air conditioner is 60% of my electricity bill, right? And I can very easily, so we saw that we can very easily disaggregate air conditioner, refrigerator, water motor, and washing machine. And together, these four constitute about 80% of my electricity bill. So with very simple things, I mean, we are not doing any fancy machine learning and all. We believe with doing many of those hidden Markov models or fancy machine learning, we will be able to achieve much more if by doing simple combinatorial optimization, we can achieve this kind of accuracy. So, I mean, what we are putting forward is that, look, even if I don't use any complicated stuff, even if someone is given this information about what is the disaggregation of 80% of the bill, and you just say that rest is miscellaneous and 20%, even that may be valuable. And I think that that's where doing research in Indian context helps, because, I mean, for example, air conditioning is not something people use, or geysers are not something that people typically use in the Western or the European context. So I think in the Indian context, there is a possibility to achieve better accuracies and to disaggregate many of these loads because of their unique nature.